Struggling to understand linked lists? Dive into this beginner-friendly tutorial and master data structures in Swift and SwiftUI today. This is the app feature that we'll be creating. The user is able to enter a new person to be stored within a list, and then enter an ID, add the person to the list, to the linked list. As you can see, my name and ID is displayed within the list. You can also filter or search for names within a linked list by typing Bob or B. It locates all the names that contains the letter B. If I type in E, it locates all the names that contains the letter E. So this is the tutorial we'll be creating. Within your SwiftUI project, create a new file and name the file person. The next thing we need to do is to define our class, which is called person. Because the linked list will be interacting with person objects. Public var my ID, which is int. We also need an initializer, public init, name, string ID, int, and then we need to assign the name to the name property of the person class. Self.name equals name, self.myID equals ID. The next thing we need to do is to create an extension. We just create that extension within the person class, but the person class is a very small file. Extension, person, identifiable, we need identifiable to loop through the values to populate the list. Public var ID int self.myID, and the purpose of lines 22 is to return the person's unique identifier. I'll just compile it. In the next tutorial, we will add the linked list nodes class. Thank you for joining us. If you found this tutorial helpful, please comment, like and subscribe. See you next week. Struggling to understand linked lists? Dive into this beginner-friendly tutorial and master data structures in Swift and SwiftUI today. This is the app feature that we'll be creating. The user is able to enter a new person to be stored within the list, and then enter an ID, add the person to the list, to the linked list. As you can see, my name and ID is displayed within the list. You can also filter or search for names within a linked list by typing Bob or B. It locates all the names that contains the letter B. If I type in E, it locates all the names that contains the letter E. So this is the tutorial we'll be creating. In this tutorial, we will implement our linked list node class. The purpose of the linked list node class is to provide a structure for the nodes to enable each node to store data and to connect the next nodes and enable traversing from the linked list in both directions. So the first thing we need to do is to create a Swift file. Name the file linked list node. Create our class that's called linked list node. Our class will be a generic class. The next thing we need to do is to create another variable, public var t, and this is the value stored in this node of a generic type of t. Type the following: public var next linked list t question mark. On line 14, we create a reference to the next node in the list, which is an optional linked list node of the same generic type. On line 12, we need to move the colon closer to var. Oh, we missed out the variable name. That should be value. The next thing we need to do is to create a weak reference. Now type the following: public var weak previous linked list node, which is also a generic and optional. So on line 16, we create a weak reference to the previous node in the list to avoid a retain cycle. This is an optional variable. The next thing we need to do is to create our initializer, our init method that will accept a generic, and then we need to assign our generic value to our private variable value. Line 16, I think it's incorrect. Oh, it should be the other way around. So it should be public. Oh, that's right now. Public week var previous. Just compile it. In the next tutorial, we will implement our linked list class. Please remember to like and subscribe. Thank you. Thank you for joining us. If you found this tutorial helpful, please comment, like and subscribe. See you next week. In this tutorial, we will start to implement the linked list class to enable the user to add and remove generic objects from the linked list. The first thing we need to do is to create a new Swift file and name it linked list. Linked list. And then type in the following: public class linked list, open bracket T, colon, sequence. The linked list class conforms to the sequence protocol, and the purpose of that is to enable the class elements of the linked list to be looped within a list. The next thing we need to do is to create the first node in the linked list. Linked list node T, which will be a generic. And then we need to create another node, which is the last node, that's called tail. Private var tail linked list node T, which is also optional. We need to create a public init method, which is the default init, to create and initialize an empty linked list. The next thing we need to do is to create a computed property to detect when the linked list is empty Now we need to create another function that's called public func append, and the purpose of this function is to enable generic objects to be added to the linked list. New node equals linked list node value, and that's the new object that we're passing it in to the linked list node. And we need to check to see if the linked list tail is nil or not. So we do safe on wrapping. If there's a value in the node, then we get that node and assign it to the next node. And then we set the new node to the previous node of the current tail. And now we need to use an else statement. So if the list is empty, we assign the new node. We assign the head to the new node. And then now we need to update the tail to be the new node, since it is the last node in the list. And then the next thing we need to do is to enable searching within the linked list. And the purpose of this function will be to return the node at a specific index within the linked list. So we need to return a linked list node generic object, which can be optional. If index is more or equal to 0, that means we start from the head of the linked list. Var node equals head. Var I is equal to index. And the next thing we need to do is to traverse through the linked list as long as there are nodes, while let current node equals to node if I equals 0, return current node, I minus equals 1. The purpose of that is to decrease the counter by 1 for each node visited. The next thing we need to do is to move to the next node in the linked list. Current node.next. And then on line 57, or anywhere after line 57, we just type in return nil. I'll just compile it. Linked list does not conform to protocol sequence. The reason for that error is because we need to implement the iterator, but we'll implement those features in the next tutorial. Thank you for joining us. If you found this tutorial helpful, please comment, like and subscribe. See you next week. Struggling to understand linked lists? Dive into this beginner-friendly tutorial and master data structures in Swift and SwiftUI today. This is the app feature that we'll be creating. The user is able to enter a new person to be stored within the list, and then enter an ID, add the person to the list, to the linked list. As you can see, my name and ID is displayed within the list. You can also filter or search for names within a linked list by typing Bob or B. It locates all the names that contains the letter B. If I type in E, it locates all the names that contains the letter E. So this is the tutorial we'll be creating. In this tutorial, we will create the iterator struct. The purpose of the iterator struct is to loop over the linked list objects and to retrieve the next object within the linked list. So the first thing we need to do is to create our new struct. And then when we create the new struct, it should get rid of this error message that we're getting at the moment. So type the following: public struct iterator iterator protocol. And we need to conform to the iterator protocol to enable the iteration within the linked list so that the linked list can retrieve the next element. Private var current node linked list node, which is a generic. And the purpose of that variable is to store the current node that's been iterated over, starting with the head node. We also need our initializer, which is our init method. Start node linked list, which will accept a generic optional. Current node equals start node. The next thing we need to do is create a next function, which is mutating. And the purpose of the next function is to retrieve the next element in the iteration. We use defer to ensure we move to the next node after the current value has been returned. And then we just return the current value of that node. The next function we need to create is called make iterator. And the purpose of that function is to create an instance of the iterator. Public func make iterator. Return iterator. So this creates and returns an iterator starting at the head of the linked list. Still not compiling. think it could be there shouldn't be this bracket there. That bracket shouldn't be there. Let me try it again. Close the struct here on line 86. And then we continue from line 73. Missed out something. I forgot to declare the variable current node. Guard let current node equals current node, else return nil. So what that does, it will safely unwrap the current node if it's nil. If it's nil, I mean there are no more elements to iterate over. Just compile it now. So that warning has now gone and it's now compiled, which is good. The next function we need to implement is called find by name. Find by name. And the purpose of this function, find by name, is to locate all the person's nodes that contains a specific string within that name. So this is the name that we're searching on. And then we will return an array of person, of people objects. The next thing we need to do is to create an empty array to store the matching results. Or the matching person object. And then now we have to start traversing the linked list from the head node. And then we also have to iterate over the linked list as long as there are nodes. That person equals node.person.value. If person name.contains name.lowercase. So if it's found, we add that object to the results array. And then we move to the next node within the list. Current node equals node.next. And then we just return the result to the user or to the calling method routine. So now just compile it again. Yeah, it should be results, not result. Compile. In next week's tutorial, we will implement the linked list view model. And please remember to like, comment, and subscribe. Thank you for joining us. If you found this tutorial helpful, please comment, like, and subscribe. See you next week. Struggling to understand linked lists? Dive into this beginner-friendly tutorial and master data structures in Swift and SwiftUI today. This is the app feature that we'll be creating. The user is able to enter a new person to be stored within the list, and then enter an ID, add the person to the list, to the linked list. As you can see, my name and ID is displayed within the list. You can also filter or search for names within a linked list by typing Bob or B. It locates all the names that contains the letter B. If I type in E, it locates all the names that contains the letter E. So this is the tutorial we'll be creating. In this tutorial, we will implement the linked list view model class. The purpose of the view model is to manage the state and logic of the linked list for a SwiftUI view. The first thing we need to do is to create a new file, a Swift file. Name the file linked list view model. The next thing we need to do is to import SwiftUI. And then decorate our class with observable. Observable is not coming up. I must be using the wrong version of Xcode. So I just switch over to the correct version of Xcode. I just switched over to Xcode 15. At observable class linked list view model. So the purpose of using at observable is to enable the class to detect for any changes. within the properties or the methods. And then the next thing we need to do is to create a new instance of the linked list object that will hold an array of person bar linked list equals linked list person. The next thing we need to do is to create a publish property to store the search text entered by the user. Bar search text and to do that we use didSet. And the didSet block will then trigger another function which will be called filtered people. Or filter people, as in filter search. So now we need to create that function, filter people. Func filter people if search text is empty. Filtered people equals array linked list. So what that does, if the search text is empty, convert the linked list to an array and assign it to the filtered people array. The filtered people variable doesn't exist as yet, so we need to declare that variable. Bar filtered people. So the filtered people will contain an array, a person array. And the next thing we need to do, so if there is something to filter by, then we need to filter the linked list. Using the information that was provided in the search text variable. The next thing we need to do is to set up default data, set up initial data. So we add sample person object to the linked list, and this will include a name, an ID, linked list, append, person, name, Alice, ID, 1, and then we add another object to the linked list, which will be Bob, and the ID for Bob is 2, and another person to the linked list, or object to the linked list, is Charlie, ID 3, and then David. And then we also have to call filter people function. And the purpose of that is because the filter needs to be done immediately after populating the initial values within the linked list array, which is here. And then we need another function to enable the user to add a new object to the linked list. And this will be done using the SwiftUI view. So just passing the parameters here. And then we add the object or the instance to the linked list. Linked list dot append person name and ID. And because we have added a new person to the linked list, we need to call filter people again so that the linked list has the updated information, and then that updated information is then refreshed on the SwiftUI view. I'll just compile it. In the next tutorial, we will implement the content view to enable the content view to call the methods within the linked list view model, and then the methods in the linked list view model will then call the linked list. So that's the tutorial for tomorrow. Thank you for joining us. If you found this tutorial helpful, please comment, like and subscribe. See you next week. Struggling to understand linked lists? Dive into this beginner-friendly tutorial and master data structures in Swift and SwiftUI today. This is the app feature that we'll be creating. The user is able to enter a new person to be stored within the list, and then enter an ID, add the person to the list, to the linked list. As you can see, my name and ID is displayed within the list. You can also filter or search for names within a linked list by typing Bob or B. It locates all the names that contains the letter B. If I type in E, it locates all the names that contains the letter E. So this is the tutorial we'll be creating. In this tutorial, we will start to add our GUI components to the content view to enable the user to interact with the linked list. Type in the following: @state private var view model equals linked list view model. @state private var new name. @state private var new ID. So the purpose of lines 13 and 14, when we create a new person, a new contact, we add a new name and a new ID to each of the records for that person. If you wanted to, we could convert this into a class, but at the moment we're using two separate variables to store the person's information. Stack spacing 20, text people linked list dot font large title dot font weight bold dot padding top dot foreground color blue. So what we've done there, we just created a little caption, a little title that will show the text people linked list at the top of the view. The next thing we need to do is to add our search and filter elements. Stack image system name magnifying glass dot foreground, that's wrong, dot foreground color gray, text field search by name, view model dot search, The view model needs a $sign at the beginning. $sign. The $sign's not coming up. Let me try it again. Dot text field style, which will be plain text field style. 10 to the padding, which is 10 pixels. Dot background color system gray 6. Dot corner radius 6. So corner radius is 10. Overlay rounded rectangle corner radius 10. Stroke, and the color for the stroke will be blue. Line width is 1. And then after line 35, we add some padding. Leading and trailing. The next thing we need to do is to add another B stack, but this time it is to enable the name of the person to be entered. And then, as we've done before, we also need a H stack to include a person built image. Dot foreground color gray, text field enter name, text $sign new name, dot padding is 10, background color system gray 6, dot corner radius is 10, overlay, and overlay, the same overlay that we created in the previous example. So I'll just copy and paste lines 33 to 34. Just compile it. In next week's tutorial, we will complete the content view. And if this tutorial has helped you, please comment, like, and subscribe. Thank you for joining us. If you found this tutorial helpful, please comment, like, and subscribe. See you next week. Struggling to understand linked lists? Dive into this beginner-friendly tutorial and master data structures in Swift and SwiftUI today. This is the app feature that we'll be creating. The user is able to enter a new person to be stored within the list, and then enter an ID, add the person to the list, to the linked list. As you can see, my name and ID is displayed within the list. You can also filter or search for names within a linked list by typing Bob or B. It locates all the names that contains the letter B. If I type in E, it locates all the names that contains the letter E. So this is the tutorial we'll be creating. In this tutorial, we will add the Add Person button, the text field ID field, and the list to show all the objects in our linked list. So the first thing we need to do is, after line 50, add another H tag. The H tag includes a system image name, which is calendar. The foreground color is grey. We also add our text field to enable the user to enter their ID. And for the keyboard side, we will use number pads. Text field style will be plain. Background, color, system grey 6. Corner radius, ten. overlay, rounded rectangle with a corner radius of 10. Stroke will be a blue color with a line width of 1. Our style shouldn't be there, it should just be dot blue. We have some padding. And trading, which is in an array. Oh, that should be dot leading. Next thing we need to do is add our button to enable the user to add a new person. If let ID equals the int, so it will attempt to convert the ID as an int to an int, So what that does, if the ID can be converted to an int and the name is not empty, then using the view model, we add that new person onto the array with the name and ID. New name, blank, new ID, blank. On line 68, the I should be lowercase I. Let me check it first. Go to the definition. Yeah, that's correct. Yeah, it should be uppercase I. The next thing we need to do on line 74, we need to add our caption for our button, which is called add person dot font headline for the style, foreground color, white, padding, dot frame, max width, infinity, dot background, color is blue, corner radius is 12, shadow, so we add a shadow to our button, color dot blue, dot opacity 0.3, radius 10, x0, y5. And then the next thing we need to do is to add a bit of padding. So just copy line 65. And now we just need to display the contents of our linked list using a for each loop within a list. Filter people, person in, vstack, alignment dot leading, spacing for, text, person dot name, on line 90, the vstack should have a bracket there at the end. It's got font, title 2, font weight, got bold, and then we display the ID for the person, which is person.id. Font, sub headline, foreground color is grey. Add some vertical padding, 10 pixels. Set the list style to plain. And then set the background color to system ray 5, opacity 0.1, corner radius 15, padding, and then we increment on a pair, and then call the view model set up initial data method to populate our list. I think we need another closing bracket after lines 109. See if that fixes it. I know what it is. On line 106, I missed out a closing bracket. And another closing bracket should be there. Still not compiling. And here's the application running. As you can see, we can filter or add a new person to the linked list. Seems like X code has crashed again. Try it again, add a new person. You can see the person has been added to the linked list. Thank you for joining us. If you found this tutorial helpful, please comment, like and subscribe. See you next week.